A, it should be multiple of 3, but remaining letters B and C, any combination, right? So what will be the regular expression? Try to design the regular expression. Any combination of B and C, but A, that is multiple of 3. So minimum 3, then multiple of 3. That's a 6, 9, like that. Design થઈ જાય. Drop the regular expression in chat box. Right or wrong? No problem. But try it. Your language, it is having the triple A, B and C, which is occurring for any number of time and in any sequence, right? It doesn't mean કે ટ્રિપલ એ પહેલા જ હોવા જોઈએ કે છેલ્લા હોવા જોઈએ, right? એવી કોઈ condition નથી. It may be in middle, it may be in last. Just look at the string. 3A. It's not the consecutive A also. Just look at properly. Such type of strings. If you are designing your RE, just check out whether your RE is accepting these strings or not. As you keep practicing, okay, you will get the exact RE. Sometimes you will get confused about, okay, this is one is a right and this one is a, okay, accepting this language. So this is the RE. You can check out. Few of the people are getting giving the right answer. So initially either B or C may be possible, any combination of B or C. So that's why B or C whole star. Then there may be a A, then B or C whole star, again A, B or C whole star. And whole star means I can accept the null string also. So if I don't want to take the B or C, I am just simply putting the null symbol. So there are the 3 A I can get, right? If I want the 3 consecutive A, I can put the null, right? So that's why the star. And whole star means the multiple of your 3. Triple A, which is a multiple of 3. Fine. So you are designing very well. Now even number of 0. Now here again, even number of 0. That's a multiple of 2. Okay. Language, same language, different way represent થઈ છે, right? Previous one છે language multiple of 3. અહીંયા આપ્યું છે even number of 0. What is the meaning of this? Double 0. So every time your 0 must be in the form of 2, 4, 6, like this way. So it's a multiple of 2. So design it. What should be the RE? Okay, fine. Right. If you are designing, okay, by your, that's too good. So this is the array for this one, even number of 0. Next one, string should have odd length. Now what is the meaning of this language? It should be having the odd length. So string that is of length 1, 3, then 5. It's a length. And just consider the input symbol 0 and 1 here. Input symbol sigma 0 and 1. Okay, any other one? Okay, so check out. Okay, either I'm accepting 0 or 1. That's a odd length, right? If your string is accepting null, okay, whole step cursor topello input null accept blank empty string, so which is not allowed in your odd length string, right? So that's why I'm compulsory first one picking up 0 or 1, right? After this concatenating it with the string of any combination of 0 or 1 two times and multiple of this. So odd length string either 0, either 1. Next, after accepting either 0, either 1, I can be having any combination of 0 and 1, right? So I can put null instead of that whole star. Are you agree with this one? You are designing, that's also you are near to the language, but still something is missing. That's I'm telling, something is missing, that is there must be odd length. So Dhwani, you're right, right? Annie, you'll be having the empty string, right? So next one after this, even length. From this previous one, you can easily design the even length. So allowed strings here, 00, 11, that is available. So look at here. It's a multiple of 2. Right. Right. So all of you other people, please try to design the regular expression your own way, please. Right. It will clear your logic. If you design right now, okay, you can be able to design the more and more R or language or RE for the language, right? Any of this. આ કઈ એવી વસ્તુ નથી કે તમે ગોખીને કરી શકો, right? Please, તમે કેટલા હારી ગોખવા જશો? There are lots of RE available for lots of language. So don't try to mug up the things. Please try to design it with your own logic. There may be a mistake, but after practice, you will get that. Please design it your own way. Not giving the answer, I'm telling to those people. Okay, try to do it in your notebook. Okay, starts with 0 and has odd length. Previous 27 number string having the odd length, you have already seen it. Okay, previous માં odd length string ની આ રીત તમને ખબર છે. But અહીંયા એક more condition add થઈ છે કે it is always starting with 0. So here in previous one, we had accepted either 0 or 1 as a first character. But here the condition is first character must be a 0. So જે previous છે આપણી એ જ replace થશે with only 0. Okay, I'm just removing the 1 here. Fine. Right, right. So it's also easy. Okay, you can easily design it. We are having the even length string and no requirement. It is start with the 1, right? It start with the 1, right? Then it can be having any combination of 0 and 1, and then any combination of 0 of 1 which is repeated. So 2 plus 2, 4 next time. It may be either 2 length, it may be either 2 plus 2, 4, it may be next time it is 6, right? Start with the 1 only, right? Okay, this is too much easy. All string begins or ends with the 0, 0 or 1, 1. So either one string start with the 0, 0 or another string start with the 1, 1. Okay, it is end with, sorry. Start with 0 there, 0 or ends with 1, 1. Anything else. In between, any possible combination of 0 or 1. It is allowed. What should be the RE? Okay. It starts with the 0, 0, then any combination of 0 and 1, but ends with the 1, 1. All string begins with or ends with 0, 0 or 1, 1. Just look at properly. It begins either with 00 or 11, or all string which is ending either with 00 or 11. Just look at. Where's the here? So this is the answer. So write down the answers also in your notebook for each of these. Now I think I should stop here for the regular expression. I will give you as an assignment more regular expression in your classroom, right? So at that time design the more, right? Now next one, we are going to start with a new topic regarding the, okay, RE is over. Okay, I think regular expression, regular language, that is over. The topic is over. I'm starting with the NFA. So stopping here, and we will be skipping to the new topic. Your new topic, that is conversion from. Okay, already you are familiar with the finite automata. You are familiar with the non-deterministic finite automata. Only the difference between finite and non-deterministic finite. The finite automata, that is deterministic. The meaning of deterministic, that means you can determine the next move. Okay, from the name itself, you can say if I'm giving the input A, what will be the next move or what will be the next state, that is already predetermined, right? That is, if one input A, obviously it goes to the state 2. If it is input B, obviously it is going to the state 3. That, like this way. So if your input A, states are determined, or you can say next move you can determine. While with the non-deterministic finite automata, right? That is, you can say you cannot determine, that is for the input A, that is exactly one state you can reach. There may be a multiple state. So that's why it is a non-deterministic finite automata. The name NF itself telling you it is a non-deterministic. That means giving the input symbol, you cannot determine whether it is reaching to the state 1, state 2, state 3 or any of this. It can be having the multiple state movement, right? So that's why it is a NFA. So this is the NFA. Already you have learned the NFA, right? And I think this is the difference. You have, okay, already Bhumika has given the idea about the non-deterministic finite automata. Now next one, how to construct this non-deterministic finite automata, that is a very much easy as compared to the deterministic finite automata, right? So here are some few of the example which is already taught by Bhumika ma'am. Okay, I just giving the introduction to NFA because now we are skipping to the topic, that is the conversion from the NFA to the DFA, and this is the most important topic. Okay, the other example we are asking into the GTU question paper also, convert the given deterministic finite, non-deterministic finite automata into the deterministic finite automata. So for this, what are the steps? Okay, so no need to cover the NFA, I hope, right? So I'm directly skipping, reaching to that conversion method. Here's a definition. Okay, are you familiar with this delta star? This already it is covered in Bhumika ma'am lectures, right? Delta star, which is a transition function, extended transition function, right? Which is for the DFA also and which is for the NFA also. That is also discussed, right? So again, moving to the conversion method. This is a delta star. Okay, this null transition is also covered. With a null, how can you design the non-deterministic finite automata? Just I'm revising what you have already learned. Okay, I'm not describing and again teaching you, please. We will directly go into our main topic. નલ ક્લોઝર પણ શીખવું જરૂરી છે. એ આપણે પછી ફરીથી આવશે જ્યારે NFA null to NFA DFA conversion આવશે. Okay, there are the two type of conversion we are going to learn after this. That is a NFA to FA, which is a one method, and another one that is a NFA null to DFA. That's a FA, right? So NFA null to NFA and NFA to DFA. So these are the steps you will do whenever you are having the NFA null. right? Now the finite automata, that is okay. I'm not this one. Is also Mika ma'am has already completed, or she has continued with this one. Okay, fine. So we directly jump to the conversion rate. So here we are having the NFA to FA. And your method, that's a subset construction method. So just note down your topic, that's a converting your non-deterministic finite automata to the finite automata. So what is a non-deterministic finite automata? That is, we will be having the finite automata with the input symbol, one of the input symbol and multiple state, which is reaching to the multiple state. So we cannot determine whether with the given input symbol we can reach to the exactly one state or two state or three state. Okay, so આપણું task શું છે કે input symbol A સાથે, right? Look at properly. So input symbol A સાથે from state 1 it is reaching to the state 2 and 3. So here it's a transition table. So whenever you will be given the such type of non-deterministic finite automata, જ્યારે પણ તમને આપવામાં આવશે, just what you have to do, just first of all make a transition table. Sometimes શું હશે, ખાલી તમને transition table આપવામાં આવશે. Okay, this is a transition table. Input Q and state Q and input A. So here state 1 input A, where it is going to the state number 2 and 3. So here you can see into the finite. So you can draw your own way the non-deterministic finite automata from this transition table, or you can make the transition table from the given NFA. So પહેલું કામ, that is, given a finite automata, non-deterministic finite automata, design the transition table, or given a transition table, draw the NFA. Fine. Next one, આપણું કામ શું છે, converting it into the finite automata. Means આપણને શું જોઈએ છે કે સ્ટેટ 1 પરથી ઇનપુટ A માટે એક્ઝેક્ટલી એક સ્ટેટ પર આપણે પહોંચવા જોઈએ. એક્ઝેક્ટલી એક, right? Determined state હોવું જોઈએ. Not like it is reaching from 1, it is reaching to the 2 also, and it is reaching to the 3 also, right? Such type of movement is not allowed into the finite automata. I agree. So આપણને આ ટાઈપનું કન્સ્ટ્રક્શન જોઈએ છે. That is our, you can say, finite automata. આપણે આવો finite automata. So that is our goal. So what is the subset construction method? What we will do? So here, this is a transition table. Okay, just we will make a copy of this. Okay, fine, no problem. We will again design. So here, what we have to do with the input symbol where we are reaching, that is, we are reaching to the particular. Here, how to design the transition table? Just give me the input quickly. Are you able to see the screen? That is,
Yes, ma'am.
I'm right now switching to the Microsoft OneNote. Are you able to see? Okay, fine.
Yes, ma'am.
So, design the transition table. All of you just give me the input here. What should be this one? Is it right? With the state 1, starting with the state 1, input A, I'm reaching to the state 2 and 3. This is from this finite automata. I have just written it, right? At the state 1, with the input B, I'm reaching to the state 4. This is right? Okay, just be with me. Okay. So, where we are on to the state 1. Your subset construction method, what it is telling, okay, find out the transition for the input symbol A and input symbol B and construct your finite automata with the new states that you are building. So here the new states we are building, that is from the state 1. If I am taking the input 1, where I am reaching to the state number 2 and 3, right? So consider this state number 2 and 3 as a new state. Suppose it is another state, that is a capital A. Okay, I will consider state number 2, 3 as a new state which we are constructing as a capital A. Later on we will name them, right? Consider the new state. This is as a whole state, right? So what is our next task? Okay, state 1. Initial state પરથી આપણે A અને B નું movement જોઈ લીધું, right? A નું movement જાય છે state 2, 3 પર અને B નું movement જાય છે 4 પર. Now whatever the new state we are generating, consider it as a new state and find out the transition from the new state to the with the input symbol A and B. So this is the method we are doing. So this is a transition. Delta transition function with the input symbol A and B. You have to write down this manually. Okay, એવું નહીં કે directly table draw કરી દો અને આપણું complete. Okay, you have to mention the these steps. Okay, so here from the input symbol A with the state 1 input B, I'm reaching to this. So this is the transition function for this. Now the new state which is constructed, this one, this is a new state. Okay, so consider if you are reaching to the one of the state, that is a 2, 3, this is my new state, right? So for this new state also you have to find out the transition with the input symbol A and B. So how will you do this? With this delta function. This delta function from the 2 input symbol A. So we are using the union function delta, okay, function for the state 2 input symbol A union with the delta state 3 union input symbol A. So what is the next movement? Just look at properly this, your finite automata, right? State 2 input symbol A, nothing. There is no input symbol which is given in your non-deterministic finite automata for the state number 2. So what we are writing, it is a dead state or it is an empty state, 5, right? Take the union of this state 3 and input symbol A. State 3 input, where we are reaching to the state number 4, and this is the state. So what is the final output from the new state? If we are providing the input symbol A, we are reaching to the state number 4. Okay, so this is a state number 4. So this state 4 is a new, it is not the new state, it is already there inside your finite automata or NFA, right? If we are constructing the new state, then only find out the transition for the new state. Now next one movement is remaining. This one, what will be the next step? That is find out the movement with the input symbol B from the new state. This is your new state. Just consider why it is a new state, because with the state 1 input symbol A, we are reaching to the state number 2, 3, considering it as a combining these two, merging these two as a new state, right? So from this merged state, we will find out the transition for the A and B input. Now give me this one, all of you. તમારે તમારી નોટમાં મારી સાથે આ વસ્તુ પેરેલલમાં કરવાની છે, right? So you can be having the idea. So here it is a B transition, this is a B transition, and give me the union of these two. What is B? Just give me the answer. This is a new table we are constructing here. So 2 પરથી B transitions પરથી આપણે જશું state number કયા પર જઈએ છે? That is 4. And with the 3 પરથી B transition 3 itself, right? So this is the way you have to write down in your notebook also. As you are constructing the new state, okay, note down this new state into your transition table. This is a 3-4. Okay. So with the input symbol B from the 2-3, we are reaching to the 3-4. Okay. And according to this NFA, it is a new state I am getting, right? So here I am having the transition table. Okay. 3, 4. So here with the new state 2-3, નવા સ્ટેટ 2-3 જે મર્જ કર્યું છે એના પરથી ઇનપુટ સિમ્બોલ A કાઢ્યો અને આ એક સ્ટેટ પર પહોંચે છે, ઇનપુટ સિમ્બોલ B સાથે આપણે પહોંચે છે એક બીજા સ્ટેટ પર, રાઈટ? અને કન્સિડર ધીસ એઝ અનધર ન્યૂ સ્ટેટ. ધીસ ઇઝ ઓલ્સો ન્યૂ સ્ટેટ. સો વોટ આઈ હેવ ટુ ડુ, ઓકે, મારે આ નવા સ્ટેટ માટે અગેન ઇનપુટ સિમ્બોલ A માટેનું અને B માટેનું ટ્રાન્ઝિશન શોધવાનું છે. સો રિપીટ ધીસ ટાસ્ક. આ ટાસ્ક આપણે રિપીટ કરવાનો છે કન્ટિન્યુઅસલી જ્યાં સુધી આપણને નવા સ્ટેટ મળ્યા કરશે. એઝ વી આર નોટ ગેટિંગ ધ ન્યૂ સ્ટેટ, ઓકે, we are stopping this process. So here again do the similar task for the 3-4. All of you give me the answer. I'm not doing, do it for me quickly. તમારા આન્સર પર હું રિલાય રહીશ. Okay, I will consider it as right. Okay, so here and we are constructing our new FA. So A transition 4 પર જાય છે. A input માટે તમે બોલો છો this one is a 4.
Yes, ma'am.
Now for the B, give me the
3.
so for the B movement it is reaching to the state 3. So here we are building the, so just look at in your transition table. Okay, what we have done from the 1 it is reaching to the 2, 3 and 4. So for the new state 2, 3 we have again find out the movement that is for A symbol and B symbol. So finding that movement we are finding the new state also, that is a 3, 4, right? So for the 3, 4 also we are finding the A movement and B movement. So we are getting the states 4 and this state 3. So these two are the new, not the new state. Other nova states nathi, right? Which are already the part of your NFA. So consider 1, 2, 3, 4 as already available states. They are not the new state. So what we have to do? We are already, so 1, 1, 2, 2, 3 and 4. So now remaining transition, okay, that is for the state 3 that you have to write down. Okay, then state 4 and state 2 which are already available છે. Okay, so this is the method. Okay, how will you construct the DFA? આપણું કામ DFA બનાવવાનું છે. That means initial state થી હું ચાલુ કરીશ, right? ઇનિશિયલ સ્ટેટ 1 થી સ્ટાર્ટ કરીશ તો A અને B મુવમેન્ટ સાથે હું કયા સ્ટેટ પર જાઉં છું તો 2, 3 પર અને 4 પર. So આ બે સ્ટેટ બનાવી દો, right? This 2, 3 as a, consider it as a new state, right? And 4 which is already available. So draw this state and draw the transition from 1 to the input symbol A and B. So this is the way we have to construct the NFA. So final NFA. Sorry. So we'll be having the final NFA. Look it properly. This is your final NFA. How to draw final, sorry, not NFA, sorry. It's a finite automata. How to draw? This is the way you have to draw as you are constructing your finite automata. So this is 1 with the input symbol initial state, input symbol A, we are reaching to the new state which is a merge of 2, 3, right? With the B we are reaching to the state 4. Okay, next new state is a 2, 3 which is a, okay, you can give a new name instead of 2, 3 but you have to mention 2, 3 that is equal to state number A, right? Or you can write it as it is 2, 3. Now from the 2, 3 A input symbol we are reaching to the 4, right? From the 2, 3 B input symbol reaching to the 3, 4 and With this, we are constructing our next one. 3, 4 પરથી A અને B બાકી છે. કમ્પ્લીટ. હવે રહ્યા કયા સ્ટેટ? સ્ટેટ નંબર 4 અને 3 જેના પરથી આપણે A અને B ઇનપુટ સિમ્બોલ ટ્રાન્ઝિશન કાઢવાનો છે, રાઈટ? So from the 3 A movement, from the 3 B movement, from the 4 બાકી છે હજુ આપણું. So from the 4 we will be having the last one. Okay, this is the last. Okay, it's a final one. 4 પરથી તમારું ખાલી બાકી. Okay, it is a final step. That's why. Now here just concentrate properly. That is જે નવો ફાઇનાઇટ ઓટોમેટા કન્સ્ટ્રક્ટ થયો છે તમારો. ઓકે, એ જે નવો ફાઇનાઇટ ઓટોમેટા કન્સ્ટ્રક્ટ થશે એમાં ફાઇનલ સ્ટેટ તમે કયા કયા બનાવશો? સો જસ્ટ ટેક કેર અબાઉટ ધ choosing the final state. Final state એટલા બનશે જેમાં જેમાં તમારો NFA નો final state as a merging state આવશે. Like here the 4 that is a final state in your NFA. So here the 4 that is again if it is available into the FA then 4 is a final state. 3, 4 is also a final state because 4 is merged with the 3. ઓકે, સો હિયર જેટલી જેટલી જગ્યાએ તમારા ફાઇનલ સ્ટેટ ઓફ NFA અવેલેબલ છે એ બધા સ્ટેટને ફાઇનલ સ્ટેટ તરીકે કન્સિડર કરવાના, રાઈટ? સો હાઉ વિલ યુ કન્સ્ટ્રક્ટ યોર finite automata from the NFA? Your NFA which is having the input symbol A multiple states instead of we will find out only one state. So we are merging those states. Merge કરેલો જે નવો સ્ટેટ મળે છે, રાઈટ? એના પછી બે ઇનપુટ સિમ્પલ અગેન તમારે ટ્રાન્ઝિશન ફાઇન્ડ કરવાનું છે A અને B માટે. નેક્સ્ટ મુવમેન્ટ જો નવો સ્ટેટ મળે તો એ નવા સ્ટેટ માટે ફરીથી બે ઇનપુટ સિમ્બોલ માટેના ટ્રાન્ઝિશન ફાઇન્ડ કરવાનો છે. That's your delta, right? So like this way as an okay, as you are getting new and new states, okay, you have to find out the transition for those new state. If you are not getting the new state at the end, okay, if we are not getting the new state in this process, we are stopping here and we are completing our finite automata. Stop ક્યાં થવાનું છે કે જ્યારે આપણે નવા સ્ટેટ મળતા બંધ થઈ જાય દરેક સ્ટેટ માટેના. લાઈક 1 2 3 માટે આપણે જે બનાવીએ છીએ, રાઈટ? જો A અને B 1, ઓકે, બે સ્ટેટ મળ્યા 2 3 2 3 માટે હવે ફાઇન્ડ આઉટ કરવાનું છે A અને B ટ્રાન્ઝિશન. તો બીજો એક નવો સ્ટેટ મળે છે 3 4. તો 3 4 માટે ફાઇન્ડ આઉટ કરવાનું છે A અને B ટ્રાન્ઝિશન. અને પછી કયા સ્ટેટ મળે છે? જો નવો સ્ટેટ મળે તો એના માટે પણ કરો અને નવો નથી મળતો દેટ મીન્સ 3 અને 4 જ મળે છે. દેટ મીન્સ સ્ટોપ હિયર, સ્ટોપ યોર પ્રોસેસ હિયર, right? And consider those as a inputs as a states inside your finite automata. So getting all of you? Any confusion? This is a subset construction method for converting your finite automata to, sorry, NFA to the FA, non-deterministic finite automata to the finite automata. Okay, so now this is another example I'm giving to you people. Okay, this is a transition table given for the NFA with the states Q0, Q1, Q2 and Q3, right? Now with this states we are having the transitions with the 0 and 1 input. So here such this you will be given the transition table and you have to draw the non-deterministic finite automata, and based on that NFA you have to find out the TFA. So all of you, this is your task. Write down this transition table and draw the NFA and find out the FA. Q3 is your final state. Write down the delta function also. Okay, if you have written this one, transition table. start writing the delta function for the particular initial state, starting with the initial state. So this is the way you have to write down the delta function, or else you just look it properly in your notebook. Up to the 3, 4 only here. So this will write down in your notebook. Then only you will get the marks. Okay, GTU માં પણ આ રીતના step by step કરવાનું છે. Directly draw કરીને નહીં આવતા. Are you getting this number of states? Just check out your answers. That's too nice. Complete your DFA. And just check out the final states also here. Okay, your DFA. તમારો final DFA છે. It is a lengthy process. Do it. શાંતિથી કરો, but એકવાર cross check કરી લેજો. And just check the final states. Final state કયા કયા બને છે ને કેમ બને છે. Okay, એકવાર જોઈ લો. This is Q3 is a final state અને જેટલા જેટલા સ્ટેટમાં Q3 આવે છે બધાને final state બનાવી દેવાનું. Here in this finite automata, During this NFA to FA conversion, from the initial state, you are getting every new state. આમાં ઓલ્ડર સ્ટેટ કોઈ રહ્યું જ નથી, ખાલી ઇનિશિયલ સ્ટેટ રહ્યું છે. બાકીના બધા જ નવા સ્ટેટ આવે છે. અને એ બધા નવા સ્ટેટ જ્યારે રિપીટ સ્ટાર્ટ થાય છે, લાઈક Q0 Q2 પાછો મળવાનો સ્ટાર્ટ થાય, Q0 Q3 પાછો મળવાનો સ્ટાર્ટ થાય. ઓકે, દેટ મીન્સ FA ના નવા સ્ટેટ જે બન્યા છે એ સિવાયના બીજા કોઈ જનરેટ નહીં થતા હોય તો પ્રોસેસ અહીંયા સ્ટોપ કરી દેવાનું છે. Is it completed? If not, just draw the final FA. ઓકે, બાકી હોય એકવાર ફાઇનલ ડ્રો કરીને ક્રોસ ચેક કરી લેજો. તો ડુ ઇટ યોર સેલ્ફ પ્લીઝ. અત્યારે બે એક્ઝામ્પલ કરશો, ઇટ્સ ટુ મચ ઇઝી. લેટર ઓન ગમે એવો એક્ઝામ્પલ પૂછાશે NFA to FA, યુ કેન ડુ ઇટ બાય યોર સેલ્ફ. પ્રેક્ટિસ કરશો બે એક્ઝામ્પલની, યાદ જ રહી જશે. પ્લીઝ. અને એક્ઝામમાં પૂછે છે, draw this final FA. Because I'm finishing today's lecture. Tomorrow we'll see the new topic. I will give you the assignment for this one tutorial. In the tutorial, the assignments it will be given for the regular expression also and for this one also. And FA to FA. So, should I stop sharing?
Yes, ma'am.
Okay, fine. So we'll meet in next lecture. Fill your attendance, then you can leave.